Everyone, since Amanda is busy, I will be recording the Math AMS for Term 3, Week 9. Okay, let's start. The first and second terms of a geometric progression are 1 over 10 and 7 over 2 respectively. What is the common ratio? So, for common ratio of a geometric progression, you take the term after and divide it by the term before. So this here, it would be the second term, 7 over 2, divided by the first term, 1 over 10. So we do 7 over 2 divided by 1 over 10. And this would give us an answer of 35. So 35 is our answer. Number 2. The first term of a geometric progression is 48 and its second term is 36. Fill in each blank with a whole number. In simplest form, the common ratio of this progression is... and the answer. So common ratio, same as the previous question. You take the term after. Here it's 36. And divide it by the term before. First term, which is 48, which will give you an answer of 3 over 4. So our answer is 3 over 4. Now for part B, the sum to infinity of this series is... To find the sum of infinity of a series, you have to use the formula. S infinity is equal to first term over 1 minus the common difference or common ratio, which in this case, when we substitute, would be 48 over 1 minus 3 over 4, which after simplifying would give you a final answer of 192. So our answer is 192. Number 3. The first three terms of a geometric progression are 5m and 30m in this order. What is the value of m? Now, there are many ways to do this question, but I will do 5m over 5 equal 30m over 5m. Now, why am I doing this? Because both of these are equal to the common ratio. 5m over 5 is second term divided by first term, and 30m over 5m is third term divided by second term, which is also equal to the common ratio. So both of these fractions are equal to each other. Right now, we just simplify. So 5 and 5 cancel, and 5m and 30m cancel here, it becomes 6. So m is equal to 6. What is the value of the common ratio of the given progression? Okay, we got that m is 6, right? So now let's substitute m back in here. So the first three terms are now 5, 6 times 5, which is 30, and 6 times 30, which is 180. Now just do the term after divided by the term before. So I'll do 30 over 5, which will give you a final answer of 6 as well. So our final answer for part B is 6. Now for part C, since R is equal to less than or greater than 1, R is greater than 1, then the sum to infinity of the given progression diverges. Whenever our common ratio, is greater than 1, the sum to infinity diverges. The first two terms of an arithmetic progression are minus 7 and 1. Fill in the blanks to give the next 5 terms of this progression. This is an arithmetic progression. So we continue and add the common difference each time. So what's the common difference for the first two terms? 1, let's do it, 1 minus 7 to get the common difference, which will give you an answer of 8. So 8 is our common difference, right? Now we keep adding by 8 each time to get the next 5 terms. So 1 plus 8, 9. 9 plus 8, 17. 17 plus 8, 25. 25 plus 8, 33. And 33 plus 8, 41. Those are your answers. Now, A is an arithmetic progression with first term A1 equal negative 15 and common difference D equals 6. What is the value of A9? To do this, we need to know the arithmetic progression formula, which is AN is equal to A1 plus N minus 1 times D. Okay? So that is the formula for an arithmetic progression. Now we just substitute it with the numbers that we have. So AN is A9 now. A9 is equal to A1 negative 15 plus N minus 1 What is n? 9, right? So 9 minus 1 is how much? 8. So it's 8 times 6, common difference. Now just simplify and you'll get a final answer of 33. Right, so our final answer is 33. What is the value of A101? Same thing as part A, just do it with 101 instead. So A101 is equal to A1 minus 15 plus n minus 1. 101 minus 1 is 100, right? So 100 times 6. So it's minus 15 plus 600, which means our answer is 585. Our final answer is 585. B is an arithmetic progression with first term B1 equal 9 and second term B2 equal 17. What is the sum of the first 20 terms of the progression B? B is an arithmetic progression. So the formula for the sum of an arithmetic progression is, I'm going to write it down now, Sn is equal to n over 2 2a1 plus n minus 1 times d. So that is the formula for sum. Now let's substitute. S of 20, sum of 20 is equal to n over 2. 20 or divided by 2 is how much? 10. 10 multiplied by 2 times a. What is a1? Or in this case b1? 9. 2 times 9 is how much? 18. Right? Plus n minus 1. What's n? 20. 20 minus 1 is how much? 19. So it's 19 times d, which is, what is d? First term minus, second term minus first term, because it's an arithmetic progression. So 17 minus 9, which is how much? 8. Now you just simplify, and you'll get an answer of, let me just do it on the calculator. You'll get a final answer of 1700. Consider the arithmetic series minus 6 plus minus 1 plus 4 plus 9 plus etc. gives plus, doesn't give, it plus 239 at the end. Wait, okay, let me start. Consider the arithmetic series minus 6 plus minus 1 plus 4 plus 9 plus etc. and at the end plus 239. So, what is the value of the common difference of the given arithmetic series? First, to find the common difference of an arithmetic series, you do the second term minus the first term, or the term after minus the term before. So here we do minus 1 minus minus 6 gives 5 as a final answer. So the value of the common difference here is 5. What is the value of the sum above? Okay, they want you to find the sum here. The problem is we can't find the sum without having n. We need to find n first. And to find n in an arithmetic series, we're going to do an is equal to a1 plus n minus 1 d. Right? Then we substitute. An here is 239, the final number. 239 is equal to minus 6, the first term, plus n minus 1 times, what's our common difference? 5. Now take minus 6 to the other side. It will become 245 equal n minus 1 d, or 5. Now divide by 5 on both sides to get your answer. So 245 divided by 5, you'll get an answer of 49. So 49 is now equal to n minus 1. Alright, so n is equal to how much? N is equal to 50. Now that we have the n, now we can do the sum. So, sum of 50, because we know n now, is equal to 50 divided by 2, which is 25. And a1 plus an, alright? It's a1 plus an here. So A1 is how much? Minus 6 plus the AN, which or A50, which is 239. So minus 6 plus 239 is equal to 233 multiplied by 25 to get a final answer of 5825. This is our final answer. So let me just put it 825. Next question. Let me just change the color. A conference hall has 14 rows of seats. There are 10 seats in the first row and 88 seats in the last row. Each row exceeds the previous one by the same number of seats. How many seats are there in total? Basically, they're telling you in code that this is an arithmetic progression for an increasing number of seats. So the first row has 10 seats, then it increases by a specific number, by the common difference, then it increases again and again and again and again and again until it reaches the 14th row, which has 88 seats. So we can say that the first term, A1, is equal to 10. And the second, and the, not the second, the last row, which is A14, is equal to 88. Alright? And they're asking for the sum. How can we do sum? Sum, let me just write the formula. Sum of 14 is equal to 14 over 2. How much is 14 over 2? 7 multiplied by A1 plus A14. So 10 plus 88, which is equal to 7 times 98, which is equal to our final answer of 686. That is our final answer. That's our final answer. Number 9. Okay, for this question, please ignore the sigma notation. Alright, and just pay attention to the n. Leave the like we're gonna use it later. Now consider the expression 9m minus 2. Use the fact that the sum of the first k integers is k plus 1 over 2 to answer the following questions. nm minus 2 is equal to n over 2 b plus cn, where b and c are integers to be determined. What is the value of b and what is the value of c? So the first thing we do for this question is we take this fraction and we substitute it into m. Alright? And for simplicity's sake, I'm just gonna swap k with n, because that's how they want it in the final answer. So let's swap it. It becomes 9 n plus 1 over 2 minus, now this is where the n comes back in. This n we distribute it onto the minus 2, so it becomes minus 2n. Okay? Now let me switch to a different color. Now we multiply by the 9, so it becomes 9n n plus 1 over 2 minus 2n. Right? Now, what do they want? They want us to take the n over 2 out. If you look in the answer, they want us to take the n over 2 out. So we have our, let me write it again, 9n n plus 1 over 2 minus 2n. We want to take the n over 2 out. First, let's make this all into one fraction, right? So here, multiply by 2 up and down, so it has the same denominator. It becomes 9n n plus 1 over 2 minus 4n over 2. Okay? Now that we take the n over 2 out, it becomes n over 2. You know what, let me write it in a different color. N over 2, 9 n plus 1 minus 4. Alright? Now, what do? You distribute the 9 onto the n 9 and plus 1, and you'll end up getting n over 2 9n plus 9 minus 4 to give you a final answer of, after simplification, n over 2 5 plus 9n. So this is our final answer. Now we match it up with the answer that they gave us. N over 2, correct. B plus Cn is 5 plus 9n. What does that mean? That means B is 5 and C is 9. Alright? So put that in the answer. B is 5 and C is 9. Now for part B. Based on the result of part A, what is the value of 7 plus 16 plus 25 plus 34 plus etc etc and then plus 358? So same as the previous question we did. First, instead of doing the sum, we need to find n first. So we use the formula for arithmetic progression. An gives a plus 1 plus n minus 1 d, which is then 358 is equal to 7 plus n minus 1 times the arithmetic progression, the common difference, which is 9. Now, take the 7 to the other side and then divide by 9 on both sides. Let me just do it on my calculator. You'll get an answer of 39. So, n minus 1 is equal to 39, and n is equal to 40. Alright? Now, we take our n being equal to 40 and we do s of 40 is equal to n over 2, 40 over 2, which is 20. A1, what's A1? 7, right? So 7 plus A40, which is 358. Now for our answer, we'll end up getting sorry, just give me a second. 7,300 is our final answer. That is the sum of all of these. Let A be an arithmetic progression with the first term -5 and common difference 10. Let B be another arithmetic progression with first term 2 and common difference 9. Let M be the number for which AM is equal to BM. What is the value of M? Alright, so first, let's find the equations for these arithmetic progressions and then we will equal them to each other. So, arithmetic progression A, M, is equal to A1, which is -5, plus M minus 1, times D, which is 10. Now, distribute. It will become -5 plus, no need for the brackets, 10m minus 10. So -5 minus 10 will give us 10m is 10m minus 15. So that is the formula for arithmetic progression A. Now, let's do it for B. The arithmetic progression for B, the equation is equal to 2a1 plus n minus 1 times 9. Alright? Now distribute the 9. You'll get 2 plus 9n minus 9. And you get a final answer of 9n minus 7. Alright, now we make this equal to our arithmetic progression A, which was 10m. Sorry. 10m minus 15. Now these two, they're equal to each other. Now we just take each one to the other side. That's an m, sorry, not an n. M, both of them are m. So we take this to the other side and this to the other side, we swap them. It'll give m is equal to 8. So our final answer is that m is equal to 8. What is the value of am? Now we take our m and we substitute it back into our equation. What was the equation for am? The equation for am was am is equal to 10m minus 15. Alright? Which means 10 times 8, 80. 80 minus 15 to give us a final answer of 65. So our answer is 65. Let B be an arithmetic progression with B4 equal to 6 and B6 equal to 32 and B8 equal 58. What is the value of B5? Alright, to get B5, we need to know the common difference. They didn't give us the common difference and they didn't give us two terms right after one another to find it. What we need to do is take our B4 and B6. How are they related to each other? B4 plus not the common difference, 2 times the common difference will give us B6. Because B4 plus the common difference will give us B5. B5 plus the common difference will give us B6. Okay? So it's 2 times the common difference. So it would be B4 plus 2D, 2 times the common difference, will give us B6. Or if we write it down, 6 plus 2D will give us 32. Which means 2D is equal to 26 and D is equal to 13. Alright? So we know that the common difference is 13. Now, to find B5, we just add the common difference onto B4. So B4 or 6 plus the common difference 13. 6 plus 13 is how much? 19. Alright? So 6 plus 13 gives us 19. Now for B9, same thing. Take our common difference 13 and add it to 58 to give you an answer of 71. So 71 is our answer. Number 12. The first two terms of a geometric progression are 512 and 256 successively. Fill in the blanks with the correct numbers to give the next four terms of this progression in the correct order. So, the common ratio here is what we multiply 512 by. Multiply 512 by to get 256. Alright? Now what do we multiply 512 by to get 256? You have to divide the second term by the first term. 256 divided by 512. It's half. So here they're multiplying by half each time. And we just continue this. Continue this progression. So 256 times half. Wait. 256 times 0.5. 128. Times half 64. Times half 32. Times half 16. So you're multiplying by half each time to get the next term. Next question. G is a geometric progression with the first term G1 equal 1 over 7 and common ratio R equal square root 7. So what is the value of G4? We need to know the formula of geometric progression here, which is G4 equal G1 multiplied by R common ratio to the power of n minus 1. So G4, I'll write it in a different color. G4 is equal to G1 1 over 7 multiplied by common ratio square root 7 to the power of 4 minus 1, 3. Alright, now we just simplify. Remember, the power 3 is to the whole thing. Whole of square root 7. So square root 7 to the power 3 times 1 over 7 will give you a final answer of square root 7. So square root 7 is your final answer. Let me just type it. Now for G7, same principle. G1, which is 1 over 7, multiplied by square root 7, the common ratio, to the power of 7 minus 1, which is 6. So just solve it. So square root 7 to the power of 6 times 1 over 7. 49. You get a final answer of 49. Consider the geometric progression 3 minus 9, 27 minus 81, 243, etc. What is the common ratio of this progression? Common ratio is the term after divided by the term before. So it's here minus 9 divided by 3 to give us a common ratio of minus 3. Right? So minus 3 is our common ratio. Part B. What is the sum of the first 6 terms of this progression? So the sum for a geometric progression is, let me write the formula. S of n is equal to A1, first term, 1 minus r to the power of n wait, let me fix this. R to the power of n over 1 minus r. Alright? That is the formula for sum in a geometric progression. Now, let's write it with all of the numbers substituted. So A1 is how much? 3 multiplied by 1 minus, you know what, let me change the color. 3, 1 minus 3 power of 6, right? Because the n is 6 here. Over 1 minus 3. Right? Okay, so that's the... Sorry, wait a second. That is all of the numbers substituted. Then, after simplifying all of that, so minus 3 power 6 will get you 729. 1 minus 729 will give you minus 728. Divided by 4 times 3 will get you a final answer of minus 546. That is your final answer. Alright? So it's minus 546. What fraction in lowest terms is equal to 0.45 repeating? Okay, so 0.45 repeating is just the same as saying 0.454545 etc etc, right? And that is the same as saying 0 plus 45 over 100 plus 45 over 10,000 plus 45 over a million, etc etc. I don't have enough space to write it, but you get it, etc etc etc. So what we're doing here is that this is an infinite series, right? It keeps on adding 45 over 100 plus 45 over 10,000 plus 45 over a million plus etc etc etc. What is the rule for sum of infinity? Sum of infinity, let me write it in a different color. Sum of infinity is equal to A1 over 1 minus r, right? A1 is 45 over 100 over, sorry, give me a second. Okay, wait, I ran out of space. Let me write it here. It's 45 over 100 over 1 minus the common ratio, which is what in this case? Do 45 over 10,000 divided by 45 over 100. And you will end up getting 1 over 100. Alright? Now simplifying this will get you an answer of 45 over 100 over 99 over 100, which is equal to 5 over 11 as our final answer. Number 16. The numbers 96, x, and 6 are 3 consecutive members of a positive geometric progression. What is the value of x? So I'm going to use the same technique as a previous question. So x, let me change the color. X over 96 is equal to 6 over x, because they're both equal to the common ratio. Alright? Second term over first term, third term over second term. Now, let's cross multiply. You'll get x squared is equal to 576, meaning x is equal to 24. Alright? What is the common ratio of the geometric progression? Now, we know that x is 24, right? So it's the first 3 terms of this geometric progression are 96, 24, and 6. Now just do second term divided by first term. So 24 over 96 will give you 1 over 4. That is your common ratio. Alright? So it's 1 over 4. What is the sum to infinity of a geometric series if the first term is 48 and second term is 36? Sum of infinity is S infinity equal to A1 over 1. This is the same as the previous question. It's the same. A1 is 48 over 1 minus the common ratio, which is 36 divided by 48, or 3 over 4. So here you'll get a final answer of 192. Find the sum of the first 40 terms of an arithmetic progression when the first term is equal to 6 and the second term is equal to 16. So, the sum of the first 40 terms is equal to n over 2, so 40 over 2, which is 20, multiplied by 2 times a1, so 2 times 6, 12, plus n minus 1 times d. Now what's n minus 1? 40 minus 1, which is 39, times our d, which is how much? 16 minus 6, 10. Our d is 10. Okay, so now you just simplify. 39 times 10 plus 12 times 20, you get a final answer of 8040. Alright, this is our final answer. Last question. Write the repeating decimal 1.090909 as a fraction in lowest terms. So, same as the other question we did, this can be written as 1.090909, etc., which is the same as writing 1 plus 9 over 100 plus 9 over 10,000 plus 9 over a million. Alright? So it's the same as saying that, and this is what, and etc. And this is what, this is in sum to infinity. Right? So we write it using the formula. A1, what's A1? 9 over 100, right? Over, note, let me erase everything, make it more clear. 9, it's 9 over 100, A1, over 1 minus R. Now what was R? It was 9 divided by 10,000 divided by 9 over 100, which was 1 over 100. Alright? Now when you simplify this, you'll get 9 over 100 over 99 over 100, right? The hundreds cancel out, and the 9 and the 99s cancel out. It will end up giving you 1 over 11. Now, there's something to remember. In our series before, it was 1 plus 9 over 100 plus 9 over 10,000 plus 9 over a million. So we need to add the plus 1 at the end. We can't forget about the 1. So this will end up not being 1 over 11 as a final answer. It will give you 12 over 11 as a final answer. Alright? Let me just put it in. Okay, let's check if our answers are correct. Inshallah they are. Okay, thank goodness. We got 100. Thank you all for watching the video.